Hello class, we're about to start section 12.5 part 2, applications of rational equations. Recall, when you are asked to solve for a specific variable, it means that you need to get that variable by itself on one side of the equation. It says example 1, body mass index or BMI is based on height and weight and is often used as an indication of whether or not a person is at a healthy weight. A BMI between 18.5 and 24.9 are considered normal. Since this index does not take into consideration what percentage of a person's weight is lean muscle, it is not entirely accurate in evaluating an individual's weight. The body mass index I is given by the formula I equals 704.5 times W over H squared, where H is the height in inches and W is the weight in pounds. Now it says here, Serena Williams is 5 feet 9 inches tall and weighs 150 pounds. Calculate her BMI. Now the first thing we need to do is this here. We need to change these feet, this 5 feet 9 inches, into strictly inches. So now, first of all, 5 feet, we know it's 12 inches in a foot. So we would take 12 times 5, which would give us 60 inches plus the 9 inches we already had. So it would be 69 inches would be the H. So H is 69 inches. Now, so we could do the formula. We would have I is equal to 704.5 times the W, which is 150, all over the height, which is 69. And then that's inches squared. Now we could put this in our calculator. So we would have 704.5 times 150. And that would give us, what's that, 105,675 all over 69 squared. To give us 4,761. Now we could divide these two values. And that would give us approximately, well, we'll round this to 3 decimal places. So our I would be, well, hold on. Supposed to just be the straight line. Our I would be approximately 22.196. And then it says solve the formula for W. Okay, now first of all, we had 22.196, so it falls into that healthy BMI, which is stated here in the earlier problem. But they just wanted us to give the numerical answer. So now it says solve the formula for W. So we would take this formula, the I is equal to 704.5 times W all over H squared. Now we want to get W by itself. So the first thing we would do is multiply each side by H squared. So we would have H squared times I is equal to 704.5 W. Now we would divide each side by 704.5. And our final answer would be W is equal to H squared times I all over 704.5. Now, one thing that I'll say, since we're doing this multiplication, let's just make this a capital I so we can distinguish that from a 1. So we have H squared times I over 704.5. And that would be your final answer for W. Okay, Eli Manning, quarterback for the New York Giants, is 6 feet 4 inches tall and has a body mass index of approximately 26.6. what is his weight? Okay, so now we would take this formula here. We already have the weight formula. W is equal to h squared times I over 704.5. So now we would substitute. We know that 6 feet 4 inches. 6 feet, we know in inches would be 6 times 12, which is 72, plus 4 is 76. So the height would be 76, and the I would be the 26.6, because that's the body mass index, all over 704.5. Now, we can put that in our calculator. We would take 76 squared times 26.6, and that gives us 153,641.6, and that's divided by 704.5. So we'll put that in our calculator. And if we round to the nearest pound, that will give us approximately 218 pounds. So it'll be approximately 218 pounds. Okay, so now we go down here, or to the next page, I should say. Okay, we have example 2. It says solve for the specified variable. Okay, so now we have b equals d sub 2 minus d sub 1 all over t for d sub 2. So we need to get d sub 2 by itself. So we know that we're going to have to get rid of this t here. So we know that we can multiply each side by t. So we will have TV is equal to d sub 2 minus d sub 1, because these t's will simplify out. And then we will add d sub 1 to both sides. So we have TV plus d sub 1 is equal to d sub 2. And that is the final answer. Now we come here to B. Now with B it says they want us to solve for lowercase n. Now if you notice here, we have a lowercase n in our numerator and our denominator. So this is what we need to do. We will multiply this whole fraction by r plus lowercase nr. So we have r plus nr, and we will multiply it by that whole equation. So we will have r plus nr is equal to, these will simplify out, and you have n times e. Now, our next step, we want to get all of the n's on one side. So we'll subtract nr on both sides. Yes?
Is that an I or is it a 1?
I believe, I thought that was a 1. That is an I. Thank you. That is an I. So let me make this into an I here. So then we will have basically I. Well, I guess it'll be I times R, and then I times NR. So we'll subtract I and R on both sides. So we have I times R is equal to NE minus I and R. Now remember, we're trying to get n by itself. So what we could do here, we could factor out an n here. So we have IR is equal to, we could factor out an n, and that will leave us E minus I times lowercase r. Now, to get n by itself, we would divide each side by E minus IR. And then our final answer would be N is equal to capital I, capital R, all over E minus IR. And that will be the final answer. Okay, now if we look here at C, we want to solve for Q here. So in order for us to solve for Q, we must first get Q out of this denominator. So what we can do is this here. Let's get rid of all the denominators. So we have P, Q, and F. We can multiply everything by P, Q, and F. Okay, so this will leave us QF plus PF is equal to PQ. Now remember, we'll want to get all the Q's on one side. So we will subtract QF on both sides. So we have PF is equal to PQ minus QF. And we'll do like we did in the last problem. We can factor out a Q. And we'll have P minus F. Now we'll divide each side by P minus F. And we'll have P times F over P minus F is equal to Q. Now one thing, I didn't make this clear right here, so I'm going to erase it and make sure that you know that this was P minus F. And that is the final answer for C. Now we come here to D. We want to get T sub 1 by itself. So the first thing we need to do is just multiply everything by this denominator here. So it'll be M times T sub 1 minus T sub 2. And we'll multiply all of this by that. Okay, so now, so let me rewrite that. Okay, so now when we multiply this out, on the left side we will have S times M times the parenthesis T sub 1 minus T sub 2. And that equals to, these will simplify out and leave you H. So now we would divide each side by S times M. And we have T sub 1 minus T sub 2 is equal to H over S times M. Now remember, we're trying to get T sub 1 by itself. So we will add T sub 2 to both sides. So then our final answer would be T sub 1 is equal to, let me straighten this line out first. So we have T sub 1 is equal to H over S times M plus T sub 2. This will be our final answer. Any questions? All right. So, on the next page, it says, in the notes for Section 8.1, we looked at the data for the number of households overall and with internet in the U.S. We determined that a model for the percent of U.S. households with computers would be P of T, and then this equation here, where T represented the number of years since 1990. It says, use this model to predict when all U.S. households will have computers by hand and by calculator.